I'm going to now take you on a quick walk through the Bronco the Skydiver when he dives out of the um, helicopter. There are four things that we can look at here. He's going to jump and his acceleration is going to be a negative 9.8 meters per second squared, but the acceleration is going to decrease the faster he goes. This is because of air resistance building up. When the air resistance builds up enough, you will get to what's called terminal velocity, and terminal velocity is as fast as he can go, so his acceleration will drop down to zero. From the initial acceleration of negative 9.8 meters per second, it will drop all the way down to zero, and he will no longer increase his speed. And this happens at about 120 miles an hour, which is about 50 meters per second. He will fall that way until he opens his parachute. When he opens his parachute, he will go through a process of negative acceleration, or you might say deceleration, which will slow him down to terminal velocity number 2. And once again, terminal velocity number 2 will be your acceleration will drop back down to zero. At this point, his velocity is slowed down to about 18 miles per hour, and that's about 8 meters per second. So let's start off with looking at the initial descent when he jumps out. So this is X, and when he jumps out, he's going to be going a little bit slowly, and then when he gets fast as he can, terminal velocity will be going faster. And so this is going to be a shallow but getting faster. So it's a shallow curve here, and then it's a steeper curve here as he's going really fast. So at this point, he's hit what's called terminal velocity, and he's going to go the same speed for that amount of time. So if I was going to draw this curve would match. This curve would match the curve below it, so that it curves right into this slope. And then he's going to fall that way for an amount of time at what's called terminal velocity, and then he's going to open up the parachute right here. So he has no parachute, he's at terminal velocity right here, and then the parachute will open right there. So he's going to open it up, and what's going to happen is he's going to slow down drastically. And so we're going to draw this as a curve going this way. So at this point he was going fast, and now he's going to accelerate the other direction. And so he's going to slow down. And so the parachute in this case has curved him toward this way, which is going to slow him down. And then he's going to begin his descent. And so once again, since this will be a constant velocity, he's going to go the same speed to the ground. So these two areas right here are what are called terminal velocity, where he's not speeding up or slowing down. The curves are the acceleration points. And so when he first jumps, he accelerates, but in this case he's accelerating downward, and right here he's also going to accelerate, but he is going to accelerate negative. So you might call that deceleration at that point, and that's denoted by the curves. So he safely arrives at the ground. So his velocity will look like this. His velocity will start off slow, and then it will begin to pick up speed, and then it will slow down. It will be almost straight during this part right here. So he's going to pick up speed, and then he's going to slow down, and then his parachute will pop open, and he will really lose speed quickly, and then he will level off right there. So there's 2 points in the trip where his velocity is going to stay the same. So the 2 points where his velocity are going to stay the same are the points where we have terminal velocity. So right here we have terminal velocity, which means his velocity stays the same, and right here we have terminal velocity where his velocity stays the same. Here we have he's going faster, and then he's going to level out, and here he's already going fast, so he's going to slow down, and those parts are accelerating downward and slowing down here. So accelerating faster and decelerating here, and I'll talk about the next two in the next video segment.